Okay. You can see A. Good. Okay. So I'm going to press the A to, I mean, there's D also. D is on the sign if you look at your calculator, okay? So alpha, you press alpha first, then you press A, okay? And then you press square, okay? Then plus by 2 times by natural log, okay? 2 times by natural log, alpha A again. Then you press plus by 0.9913, right? So I'm typing in our equation. Then you press alpha solve. So when you press alpha solve, you see what happened, or alpha equal, okay? Alpha equal 0. So that's the whole equation that we have just typed into the calculator, okay? So you want it to solve, you press shift, calculate, okay? You press shift, okay, calculate, and they say calculate A, yes, you press shift, calculate again, then you wait. You wait for a while. Okay. Oi. Still thinking. Remember.
What do you do after it says A again?
Huh?
What do you do after it says A question mark? How do you
You
choose
you
A?
you you do it again. You press shift solve again.
Okay.
So we have a value coming out. So using the solver, can you, what are you seeing now? Are you seeing my tablet or no? Okay, so using, can you see what I'm writing now? Yes or no? I'm confused now.
Yeah.
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 Okay, I'm confused. I don't know whether is it the camera or me now. Okay, using the solver, D is equal to 1.284 inches. Do you want me to show you again on the calculator, or you are okay? Yeah, okay? Okay, so I think if I got no reply, means all you have no problem. Okay. So now we know that D, okay, now we know that D is equal to 1.284. Okay. But this does not mean we already we done it already. Now we have to check. Okay, we have to check if, okay, check if check, not if, not the check whether L over R is less than 133.68. Okay. Now, why do we need to check? This is because we assume, okay, we assume that L over R is less than 1336. So we assume that we are in this region, between region A and region B. We don't know, because we don't know our, whether is it valid, because we don't know what is our R value, okay? Or what is our R value? Our R value is related to D, okay? So now we can check, okay? So we know that R is equal, we have this expression, we know that R is equal to 0.2887 D. Okay, so this will be equal to 0.2887 multiplied by 1.284. So this is equal to 0.3707 inches. Okay. So now we just need to do L over R. So our length, which is equal to 62.4, divided by radius 0.3707. So 62.4 divided by 0.3707 is equal to 168.33. Okay. Now this value is bad news. Why? This is because 168.33 is greater than what? 133.68. Okay. If we use this dimension. Okay. So from here, therefore, D, which is equal to 1.284 inches, is not valid. Okay, it's not valid. So our structure, we cannot use this side for the analysis. We have to use the right-hand side. Okay, because we realize that when we solve it using L over R is less than 1.66, when L over R is less than, why did I say 1.66? Sorry, when we use L over R, which is on the left-hand side, okay, or L over R equal to 133.68, the regime on the left-hand side, the value is wrong. Okay, why the value is not wrong, is not suitable, because our L over R is what? 168.33 when we use what? 0.3707. So now we know that our structure, we have to analyze our structure between B to C. Before that, we did not know. Now we know. Okay. So coming back, okay, so this option is not possible. Now we have to use, okay, now we have to use condition number 2. So now condition number 2 is L over R is going to be greater than 133.68. So when we use L over R is greater than 133.68, let's go back to our equations again. Okay. So we now know that, so between B to C, right? So between B to C, as you can see over here, we have to use equation number 2, where stress critical is equal to 0.877 stress E. Okay, so now we're going to apply that. So we are going to apply stress critical is equal to 0.877 stress E. Okay. So again, we are going to calculate, we are still going to do the same calculation where we going to declare P allowable or stress allowable is equal to stress critical divided by 1.67. Okay, so this will be equal to, so in the sense that we are going to calculate based on P allowable over A, right? So this will be equal to stress critical. So now this is 0.877 stress E divided by 1.67 now. Okay. So we know that our stress allowable is equal to 24 times 10 to the power 3. So this is equal to 0.877 divided by 1.67 is equal to 0.5251. A multiplied by stress E. Okay, so this will be equal to 0.5251. Area is still the same, 3d squared. Stress E is equal to pi squared E over L squared R squared. Okay, and then anything else? Nope. Okay, so now we can just very easily plug in the numbers now. So this will be equal to 0.5251, okay, 3d squared. So we can have pi squared. Young's modulus is equal to 29 times 10 to the power 6. And then the whole thing, the length is equal to 62.4. And then the R squared is equal to what? R squared is equal to 0.2887D. 0. And the whole thing squared. Okay. I want to be sure that I did not miss out anything. No, I did not miss out anything. Okay. So this will be equal to 24 times 10 to the power 3 is equal to 0.5251 times 3 times pi times 29 power 6 times 0.2887 times 0.2887 divided by 62.4 divided by 62.4. So this will be equal to 9.6513 d to the power 4. Let me try again. 251 times 3 times I shift by 1, shift by twice, 29 power 6, 7.2887, divide 62.4, divide 62.4. Yep, 9.615. So d to the power 4 is equal to 24 power 3 divided by 9. Hold on, I think I missed up something. 0.5251 times 3 times by shift by 1, 29 power 6 times 5.2887 times 0.2887 divided by 62.4 divided by 62.4 times 10 to the power 3 d4. Okay, so d4 is 24 times 10 to the power 3 divided by 9.6513 times 10 to the power 3. So 24 power 3 divided by 9.6513 power 3 is equal to 2.4867. So therefore D 2.4867 power by 1 over 4 is equal to 1.2558. Okay. So now when you have this value, right, we are like before, we are going to check. Okay, we are going to check that L over R, or not L over 2, come on, EJ. L over R must be now be greater than 133.68 when D is equal to 1.2558 inches. Okay, so we have to check. So we know that the radius or radius of gyration R is equal to 0.2887 multiplied by D, which is 1.2558. So this is equal to 0.2887 times 1.2558. So it's equal to 0.3625. So from here, we are going to do L over R. So length is equal to 62.4 divided by 0.3625. So 62.4 is equal to 172.138. So for this case, this is greater than 133.68. Okay. So therefore, D is equal to 1.2558 inches is the valid answer. Okay. Okay. So this is the most last section that I'm going to teach on buckling, which I will examine you all of you. And this is for centric loading. Okay. And this approach, whenever you see this question, this approach that we have just done, okay, requires to define, okay, using the what? Allowable stress design. Okay, allowable stress design. Okay, what I propose that we go for a 5 minutes break, and then we come back at 8:10. Okay, and when we come back, we will start on the new topic.
Yuxin, I have a question.
Can we take a break